मॉर्निंग स्टूडेंट्स। लॉज ऑफ मोशन में अभी तक हम लोगों ने फ्रिक्शन रिलेटेड जो भी डिस्कशन किया उसमें हमने काइनेटिक फ्रिक्शन के बारे में बात की और उसके कंसेप्ट को समझा और उसमें कुछ न्यूमेरिकल प्रॉब्लम सॉल्व किए। नाउ वी विल टॉक अबाउट स्टैटिक फ्रिक्शन। सपोज दिस इज द rough surface. An object is kept over here. Friction exists only if either the object is in motion or force is exerted on the object and there is tendency of motion. Means action of force is mandatory or the motion in the object is mandatory. When the object is in motion, kinetic friction acts on it. And when the object is kept on the rough surface and the force is acting on it and the object is not in motion, in that case only static friction acts. Static friction means object is static even though force is acting on it. That is the significance, that is the meaning of static friction. Now a force F is acting on this. Mass is m. Force is exerted but the object is not in motion. We suppose any object is kept on the surface. We apply some force. It is not in motion. Further we increase the force. Further increase the force. Time comes when the object starts moving. Till that time, whatever force is applied and whatever backward force is acting on it, because external force is applied, object is not in motion. It means there must be some force which is balancing the external force due to which the object is not in motion. So the backward force is between the contact of the surfaces, isn't it? That is the only external force apart from the external force which we are applying. So that frictional force which is acting on the object and opposing the applied force, that is called the static friction. Are you getting what? So applied force is there, object is not in motion. It means there must be opposing force and that opposing force is called the static friction. So gradually if we go on increasing the force, so time comes, as I said, then it starts moving. So that situation, whatever frictional force is acting on the object is called the limiting friction. F is equal to 5 Newton, but the object is not in motion. Means backward force is applied, backward force, frictional force is acting, right? This force is in this direction, frictional force is in opposite direction, isn't it? And since body is not in motion, so this force is called the static friction, denoted by Fs. The backward force, as long as the object is not in motion, so this force is called the frictional force and it is denoted by Fs. This is called the static friction. Force is applied, the mass is not in motion, right? F is 5 Newton is applied, mass is not in motion. Again F increased to 7 Newton, still not in motion. F applied 9 Newton, still not in motion, right? When the force applied is 12 Newton, the body just starts motion. So this force applied and backward force is something, frictional force is Fs1. Here friction is Fs2. Here Fs3. These are the frictional forces when applied force is this. This is applied force, and these are frictional force, or this in short I will say it is friction. So friction is for F, this is Fs1, for this another F, this is Fs2, for this F, Fs moving, this is called F limiting, and this is denoted by Fl, or this is the maximum frictional force acting on the object because it just started moving. So we can say Fl is equal to F maximum static frictional force. Are you getting what? Applied force is something. If we go on increasing the applied force, this Fs also goes on increasing. Right? In this case, what do we see? Okay, since the body is at rest, two forces are acting, one applied force and another static friction, and body is not in motion, means net force along the horizontal direction should be equal to 0. It means this force must be equal to Fs1, this force must be equal to Fs2, this force must be equal to Fs3. And limiting friction, the maximum force which is opposing the motion of the object is 12 Newton. It means F limiting must be equal to 12 Newton. After that, when it starts moving, then static friction will not be acting on this. At that time, kinetic friction will start working. Right? So this can be understood like this frictional force is called a self-adjusting force. Frictional force is self-adjusting force. Why it is self-adjusting? Here 5 Newton is applied. So this Fs1, the opposing force, body is not in motion. It means Fs1 will also be 5 Newton, backward force acting on this. Applied force and backward force Fs1, and both are equal. That is why this body is not in motion. Similarly, here this Fs2 must be equal to 7 Newton. Here that is 9 Newton. Means if you go on increasing the applied force, friction force is also getting increased gradually till that time, as long as it is static. The moment it starts moving, friction force will be the maximum one. That is the limiting friction, maximum friction acting on it. That is called F limiting or Fl, and this is the maximum static force. It is self-adjusting force. Friction is the self-adjusting force, particularly static friction. Kinetic friction is the constant one. I have already told you previously. It can be understood in this way. See, this is the string. One block is kept. I have applied some force on this. This is the string, right? And this is the mass. अभी हमने क्या किया, स्ट्रिंग है, ये मास है, F फोर्स अप्लाई किया उसके ऊपर, ठीक है. सो F फोर्स इज बीइंग अप्लाइड एंड अकॉर्डिंगली इसमें टेंशन क्रिएट होता है, ठीक है. सपोज that is external force applied and the tension in this, and I will write tension over here. F applied is suppose 5 Newton. 5 Newton force is applied, but what will be the tension backward force, because it is at rest, the mass A is at rest. When 5 Newton force is applied, object is at rest, means tension will also be equal to 5 Newton. Are you getting my point? Suppose F is 6 Newton, another tension will act, that will also be 6 Newton. Body is at rest. A is at rest. That is important. It is connected to this. Force is being applied, so tension will increase. When 5 Newton force was applied, tension was 5 Newton. A is at rest, because it is connected to this, it is not moving. Again 6 Newton, T2 will be 6 Newton. Suppose F is 10 Newton, T3 is equal to 10 Newton. At F is equal to 15 Newton, the string breaks. At 50 Newton, string breaks. So this will called, it means this is called breaking strength. Breaking strength of the string. What do we conclude? Okay, as F is increasing, tension increases till it breaks. Means here tension is also the self-adjusting force. As we go on increasing the force, tension goes on increasing. Likewise, here static friction is also a self-adjusting force. As we go on increasing the force, static friction goes on increasing as long as it is at the object is at rest. The moment it starts moving, the maximum friction is called the limiting friction, and it is denoted by FL, and it is called the maximum static friction also. Is it clear? Now we will proceed further explanation I will give. Now we will look at the laws related to static friction. This is the body A. It is at rest. Even though force is applied, the object is at rest. Backward force, that is frictional force, is acting. So here, as in case of kinetic friction, we have seen that frictional force, kinetic friction, is directly proportional to normal reaction. In the same way over here, F limiting is directly proportional to normal reaction acting on this mass. F limiting, or we can say F limiting, is directly proportional to N, or F limiting is equal to mu S into N. This is the law of static friction. This is important. F limiting, not Fs. Static friction is variable. Variable in the sense it is self-adjusting, goes on increasing. I am talking about the limiting friction, the maximum friction before it just starts moving. That friction is directly proportional to normal reaction, and this is the constant of proportionality, and this is called coefficient of static friction. So F limiting is equal to mu S, it is into N. N is the normal reaction. Suppose here normal reaction, N is acting, it's mg's gravitational pull, mg downward it is acting. So that is FL is directly proportional to N, that is mu S. This is the formula which we will be using very frequently in solving the numerical problems. Same thing over here, coefficient of static friction. Now, if we go on increasing the force, when limiting situation arises, means the frictional force is the limiting one, the maximum frictional force. At that time, slight increase in the applied force, body starts moving. The moment body starts moving, static friction does not work. At that time, kinetic friction starts acting on it. And this coefficient of static friction, we will take coefficient of kinetic friction, right? One thing is there which is required to be remembered, that coefficient of kinetic friction is always less than the coefficient of static friction. Very important relation. This should always be remembered. Coefficient of kinetic friction is always less than the coefficient of static friction. It is the thing you have to remember. So in the numerical problem also both the things are given, mu s and mu k. When the body starts moving, so at that time whatever frictional force we have to calculate, that is the kinetic friction, right? And as long as it is at rest, we will be using the coefficient of static friction. angle of friction. This is an object kept on the surface, right? Some force is applied. FL, as per this law, that is maximum frictional force is directly proportional to normal reaction, and we will use this. At the maximum frictional force, the limiting condition, what is the relation? This is the normal reaction, right? And this is the mg acting downwards towards the center of the earth, the gravitational pull. So this is the normal reaction on this object A, and this is FL. So net force acting on this will be along this. That is the net force acting, resultant of limiting friction as well as the normal reaction. So we can make the triangle, we can find the resultant of these two forces. See, this is backward, in this direction frictional force is acting, and the coefficient of friction is S, mu S, coefficient of static friction. That is the limiting friction. This is the normal reaction. So this is the resultant of two forces. Which are the two forces? FL acting on this mass, normal reaction acting on this mass. So resultant of these two forces is R. So by triangle law of vector addition, because this is a vector quantity, normal reaction is vector quantity, these are the forces, they are vector quantities. So these will be added as addition of vector is being done, right? So this is the resultant, this is the normal reaction, this is FL, direction of normal reaction is this, direction of FL is this. So by triangle law of vector addition, this is the resultant. So angle made by this normal reaction with the resultant, this is called the angle of friction. Angle of friction, right? This is angle of friction. So we can see from here, if you are taking magnitude of normal reaction and magnitude of limiting friction, in that case, in this triangle, this is 90 degree. So tan theta is FL upon N. So tan theta is equal to FL upon N. So what is FL? FL is equal to mu S into N. Therefore, tan theta is equal to mu S into N upon N, and N will go. Therefore, tan theta is equal to mu S. Means the tangent of angle of friction, that is equal to coefficient of static friction in this case, right? This is the question you see. Mass is kept, right? 10 kg mass. Coefficient of static friction is 0.3 and 50 Newton force is applied. So what is required to find? What is friction? इसके ऊपर फ्रिक्शनल फोर्स कितना एक्ट कर रहा है एंड द लिमिटिंग फ्रिक्शन, दैट इज द मैक्सिमम फ्रिक्शनल फोर्स. अब देखिए हमने क्या बताया है कि FL is equal to mu S into N. This is the standard formula. That is for limiting friction, means it is the maximum friction acting. Limiting friction, it is limiting one, and it is called FMS also, that is maximum static friction or the limiting friction. You see, what is the, if you are making free body diagram of this, so 10 G will be acting downward, so we will assume G is equal to 10 meters per second square. Normal reaction, suppose it is N, so frictional force will be acting Fs, opposite direction. So first we will find the limiting friction, maximum friction acting. So normal reaction is how much, since in the vertical direction there is no motion of this mass, means in vertical direction the object is in equilibrium. Therefore I will say N is equal to 10G. That is 10 into 10, that is 100 Newton. Right? 100 Newton is the normal reaction. So according to this, FL, the maximum frictional force is mu s is 0.3 into normal reaction is 100. That is how much? That is 30 Newton. That is the maximum frictional force acting on this. Right? Here, the 50 Newton force is being applied. Maximum backward frictional force, so acting is 30 Newton, means the object will not move. Right? Because फ्रिक्शनल फोर्स इज सेल्फ एडजस्टिंग फोर्स. जैसा हमने बताया, जैसे हम फोर्स बढ़ाते जाते हैं फ्रिक्शनल फोर्स बढ़ते चला जाता है. सो जब तक स्टैटिक कंडीशन में, जब तक मोशन स्टार्ट नहीं होता है, वी कैन गो ऑन इंक्रीजिंग द अप्लाइड फोर्स. सो कब तक अप्लाइड फोर्स बढ़ा सकते हैं? जब तक ये 30 न्यूटन नहीं हो जाता है. इट मीन्स एज लॉन्ग एज it is not in motion, the applied force must be equal to frictional force because body remains at rest. So in horizontal direction, net force must be equal to 0, then only object will be at rest. Therefore, this applied force must be equal to frictional force in this case because the limiting friction is 30 Newton. FL is 30 Newton. Means maximum frictional force which can be observed being applied on the object in this case. Therefore, whatever applied force is there, frictional force must be equal to that. In the limiting condition, applied force will be equal to 30 Newton, backward force is 30 Newton, and the object will be about to move. As long as it is less than 30 Newton, body will be at rest, and frictional force in this case will be equal to 50 Newton. Therefore, Fs is equal to 50 Newton. Because it is at rest, so this force must be equal to the frictional force. So Fs is equal to 50 Newton in this case, and the limiting friction is 30 Newton. So these are the answers of this question. Right? Concept is clear. So we will solve more and more problem in this. Right? So we will meet again with more problems on this particular bit, and till then, all the best. Take care.